Hey guys, Michael McHenry here, and I've got my AP Physics final project to show you guys. So here it is, here's the machine. Our book is down there, and the machine goes all the way up the stairs until it kind of starts right down here with our classic Newton's cradle. So basically, this is how I'll start the device. So I will lift up the ball like so, and the resulting force of the ball will be translated through the rest of the balls, causing the other ball to pop up. So when I do it for real, I'll pull this ball back a lot farther, so the resulting force will be a lot more. So this ball will go farther, and it will run into this domino. So it'll hit right at the top of this domino here. That'll be exerting a torque against the axis of rotation for the domino, which is down here. This will cause this domino to fall over. And while it's falling, though, it will hit this other domino, doing a similar thing that the balls did, resulting in all these dominoes hitting each other and falling down. Then at this last domino here, when it falls down, it will exert its force on this ball here. It will overcome the force static friction between the ball and the book underneath, causing this ball to roll down this track. So with the ball rolling down the track, at the start here, it's up a lot. It's up higher than it is at the end, as you can see here. It's up a little bit higher, so that means it will have the greatest gravitational potential energy at this point, where it's stopped at the top. But as it rolls down this ramp, that gravitational potential energy will gradually be converted into kinetic energy as it goes down, because of course energy has to be conserved in most systems. So by the end, all that potential energy it has up here will have been converted to kinetic energy. So then, also a little bit of heat energy, I guess, but the friction between the track and the ball is pretty low, so I wouldn't count on too much, but there might be a little bit. So once it gets to the end here, the ball will roll for a short bit on the cover of this language of composition book, and it will eventually, when it reaches the end, no other forces will be really acting on it except for gravity. So this means it will be flying as a projectile. I guess there'd be a very small amount of air resistance, I guess, but once again, like the friction force, pretty negligible. So that'll mean the ball will fly in sort of a parabolic arc sort of thing, and it will hit this end of this arm right here. As you can see, there's a little arm, and this will exert a torque on this outside part of the arm. Now these arms I built, they're built out of Lego. Their hinges are almost frictionless, so that torque will cause the arm to rotate and cause that other end right down there, that gray end, to hit these dominoes, just like we saw at the start here with the balls, only this time it'll be with the arm. The arm will hit the dominoes. Those dominoes will once again all fall down, just like I said before, and they'll hit another ball. This project is vaguely golf themed. I used a lot of golf balls, and I also have some green felt to make it look like holes and stuff. So it will hit this ball. This ball will roll. This ramp here, I don't know if you can see it. This placemat, I guess, it's at a slight incline. So that means that the ball will roll down this, and then it will hit this sort of ramp thing here, and that will kind of direct its motion by using the normal force of the ramp towards this car waiting on a Hot Wheels track. So basically what will happen is our ball will roll down and it will hit the back of this Hot Wheels car. So this ball will be rolling with some momentum, and once it hits this car, the system, I guess you could say, the momentum system will have more mass, like the car and the ball combined rather than just the ball. So that means that because momentum has to stay the same because of law of conservation of momentum, both the ball and the car will both have equal amounts of momentum, I guess you could say. So basically so that means the speed of the ball will be reduced, and the speed of the ball would increase for this car. So then, after being hit, the car will be here at the top of this long ramp. It will have mostly like gravitational potential energy, but as it accelerates towards the bottom where there's a nice cup down there, then at the bottom it will have mostly kinetic energy, as it's not up as high, and all that potential energy has to be converted to something because it's not just evaporating into thin air. it's going to be turning into kinetic energy as it reaches the bottom. So like I said, down at the bottom we have a cup. That is mostly to catch the car as it goes down, and that cup will slide into a arm very similar to the one we have up here that we used to hit the dominoes down. So basically that arm then will also turn with the force, with the torque exerted by the cup, will cause the arm to rotate, hitting this ball here, and that ball will be sent down this ramp and once again directed around, and it will fall down that ramp, the blue ramp, and it will enter this golf ball launcher. The golf ball launcher will fire the golf ball at this this juice carton, this empty plastic juice carton. On top of it is a weight. It's filled with coin. It's basically like it's a little plastic container, and it's filled with coins. It's connected via pulley to this desk here. So it's a little bit precarious to get down on these stairs. There's so much stuff going on. I don't want to mess any of it up. So I'm going to pause the video now. I'm going to go down there, and I'll pick up from there where I left off with explaining this. Alright, and we're back. So back where we left off, here with the carton and the weight attached on top. There you can get a better view. So this weight is attached to this pulley right there, as you can see. It's right here. So basically this pulley then, the string is attached to it, and it leads underneath here to this. Now this bar here is what is holding up this it's like a little desk that moves up and down. So basically this little bar here is holding up the desk using it's keeping it from sliding using right now it's mostly using frictional force between the rod here and this bar. So that's holding up the weight of this desk and also this golf club, which we'll get to later. So basically, when this juice carton is hit out from underneath our weight, the weight will move down because the force gravity it exerts is higher than the force friction that the desk kind of bar thing is exerting on this. So basically the weight will cause the force tension to increase through this pulley and cause it to pull the string out this way, causing this to collapse and the whole desk to move down. Now when the desk moves down, that's where this golf club comes into place. The golf club is being held up right now solely by the desk. So once the desk falls down, the golf club is free to move off of it, and it's attached to a pulley here. So it's like a big zip line. And this golf club will then accelerate down towards the bottom here. So just to give you guys a little bit of a better view here. So basically our club is up there. Once released from the desk, it will slide on that on sort of zip line, and it will slide down here until the pulley hits this clamp here. Once it hits the clamp, the pulley will stop moving. So the golf club is free to swing a little bit. Has a little bit of give in there because it's attached via rope. So basically, the golf club will hit this clamp and it will swing. So the club itself will only swing, and it will slam into this it's like a foam roller. So then basically the golf club head will hit right at the top. This will exert a force on our axis of rotation, which is this kind of bottom here. This will cause this green thing to collapse. Now, similar to what we have upstairs with the golf club, we also have a weight-filled Tupperware, not a Tupperware, I guess a plastic container filled with coins. This will act on the same principle that the last one did. We have it attached to a pulley, and that pulley is attached to our physics textbook, as you can see there, physics. So that's attached via a little binder clip. So basically what will happen is once this green roller is knocked out from under the underneath the weight will fall and it will pull on the pulley, which will create force tension, and this force tension will overcome the force of gravity acting on this book cover, causing it to pull up, over, and closed like that. As you can see, 18th hole, vaguely golf theme. So yeah, that's a basic rundown of our Rube Goldberg machine. Next, I'll show you guys my trials. Hey everybody, welcome to trial number 1 of the Rube Goldberg machine. Alright Emma, go ahead, start her up. A little misfire there. Go ahead, hit it a little harder. Okay, hey everybody, welcome to trial number 2. As you can see, we have a new yellow golf ball in there to signify that this is trial 2. The last trial, trial 1, had a white golf ball. Now we have yellow because this is trial 2. Alright, Emma, take it away. Alright everybody, welcome to trial number 3. Final trial. We have a pink ball now down here, where we had the yellow ball in trial 2. We now have a pink ball, signifying that this is trial number 3. Alright Emma, take it away. Hey guys, it's Mike. Alright, so just to finish out, I want to do a little reflection and discuss the challenges, adjustments, and things that went well on my physics project. So basically, the one component of this thing that worked really well, like amazingly well, like I don't think it ever failed, were our dominoes. Let's see, there they are. Yes, and there's some more up here. Yeah, dominoes, they always fell, they always worked. I think in all my trials, I don't think the dominoes ever failed. Perfect. Excellent. Nice work, dominoes. Then also another good part of it were these, the Lego arms, of course. We have one up here, and there's that one down there. Both arms worked well. They did their jobs pretty much perfectly. They did exactly what they were designed to do. I only had to make some modifications to the design just to make sure they fit properly and worked well with what I wanted them to do. And yeah, so moving on to some challenges I experienced. First one, probably one of the bigger challenges I had was with this Hot Wheel car here. As you can see, good old Lamborghini. It's as you can see, there's some tape there that's meant to hold the track up on the stairs. And the problem was that tape was creating some unnecessary friction between the car's wheels and the track, which caused it to kind of stick a little bit when it was just sitting there on the track. So sometimes our golf ball, right there, would roll down and it would hit the back of the car, and the car wouldn't roll, which would be a failure, and that was kind of annoying. So I had to adjust the car so that its end was just off the back of the track, just to make sure that the ball could hit it, even with a small amount of force, and still have the machine work. I'd say that the most difficult part of this, the most challenging part of this whole build here, this whole machine, was this middle section right here. So you see we've got the ball maze, and perhaps even more challenging right down here. If I can get it, there we go. The golf ball shooter, and our weight and carton. So basically, the golf ball shooter was really inconsistent. It sometimes would shoot out really fast, powerful balls, you know, and sometimes it just wouldn't shoot very fast at all. We had to make some adjustments to the machine. We had to make some adjustments to the distance between our carton and our launcher, just to make sure that even if it fired a little bit of a kind of a wimpy shot, it would still be enough to knock down our juice carton and release the golf club. Yeah. And then finally, probably one last challenge I had to contend with was how to make these weights that I used. So basically what I did was I took some plastic containers, I cut some holes in there, and I strung some string through it. It took me a few iterations with the string to figure out like a good system that actually had like tight knots, and that enabled me to like not have it mess up not have the string get all unraveled every time I ran the machine, so I could do multiple trials more easily. And yeah, that's worked. I had to change the knot to kind of like this type of thing here, which it worked well after I made those adjustments. So yeah, there's just some adjustments, some challenges, and some things that went well on my physics project. Hope you enjoyed.